If you ever had to size an expansion tank, add glycol or water treatment chemicals, or troubleshoot a short-cycling hydronic heating system, you've probably asked or been asked how much water is in the loop. Knowing this system volume is one of the rarely discussed details that can make a big difference in performance and longevity. Welcome to Boiler Room Detective. I'm your host, Ray Wohlfarth. Why should you know the volume of your hydronic system? If you undersize the expansion tank, pressure will spike when the water heats and lifts the relief valve, leaking water. Oversize it and you waste money and space. You need the system volume to get this right. If you're adding glycol for freeze protection, you need to calculate how much to buy and mix. No one wants to pay for 5 extra gallons of glycol. A system with low water volume may short cycle and cause thermal shock. Knowing the water volume can help determine if you need a buffer. Just like antifreeze, treatment chemicals need to be dosed on a total system volume. Over and or undersizing can cause corrosion and scale. So how do you estimate the water volume in a hydronic system? There are lots of shortcuts and rules of thumb for guesstimating system water volume, but I'm a little leery of their accuracy. The most accurate method is if you have access to the original mechanical drawings, and even with this, it's only about 85% accurate because you don't know what the mechanical contractor installed behind the walls. This allows you to measure piping seated at a table rather than trying to access piping hidden behind walls. The second most accurate is to pace off the piping and make your own drawing. The easiest method to use is if you use a water meter when filling an empty system. If the piping doesn't have a water meter, I use one that connects to a hose to fill the system. While this is easier, venting the air from the loop could be a nightmare. It could take hours, maybe days, to remove all the air pockets from the system. This is not a good idea on an existing system already filled with water, as it introduces fresh water, which increases treatment costs. You calculate the system volume by adding the volume of the boiler, piping, heat emitters, and sometimes the expansion tank. Let's look at the water volume for this hypothetical small hydronic loop. The system has a Crown model AWR070B boiler and an Extrol 30 expansion tank. Looking on the boiler manufacturer's website, we see that the AWR-B boiler has a water content of 2 gallons. Next, I look at the heat emitters. Based on the information provided by the fin tube manufacturer, Slant Fin, we see the 3/4 inch fin tube has 0.23 gallons per foot. We have 9 feet of basement radiation, which comes out to 0.21 gallons. The next step is the expansion tank. Look for the acceptance volume. This is how much water is in the tank. In this case, it's 2.5 gallons. The difference between tank volume and acceptance volume is the air inside the tank. If the system has an old circular metal expansion tank without a diaphragm, you may have to do it old school by using this math formula. You take 1/2 of the tank diameter and square it. Multiply that by pi, 3.146, and multiply that by the length of tank in inches. Once you get that, you divide by 231, and that will give you the gallons of water. For example, if we're going to calculate the water volume of an 18-inch diameter expansion tank, 24 inches long, it comes out to 26.47 gallons. The tank would typically be half full because we want air cushion up on top, so we would go to half of that, which is about 13 gallons. The final step is to calculate the water capacity in the pipes. Our pipe is 3/4 inch copper tubing, which has a capacity of 0.025 gallons per foot. So we add up all of our piping. That's 39 feet of 3/4 inch copper tubing. Then we subtract the 9 foot of fin tube radiation, and we have 30 feet of copper tubing. 30 feet times 0.025 is 3/4 of a gallon or 96 ounces. So we add these together. Piping volume is 3/4 of a gallon. The boiler is 2. The expansion tank is 2.5. And the fin tube radiation is 0.21 gallons. We have a total of 5.46 gallons in the system. Now that we know the formula, I want to give you some of the rules of thumb. Final thoughts. It's easy to overlook, but knowing the water volume in your hydronic heating loop can help you prevent pressure problems, save on chemical treatment costs, and optimize system performance. Whether you're a service tech, an engineer, or just a curious building owner, it's a number worth having. My boiler books are available at Pronto Heating Supplies in New York and on Amazon.com. My articles are included in many of the industry publications. Thanks for stopping by, and I'll see you on the next case.